applications of AI these days in automation. You see that in industry a lot, where you have industrial automation, and you also have AI being used in industrial automation. And so in industry, if you look at the evolution of industrial processes, you will see that things have really gone fast. Now, you can reduce the time it takes to produce certain products, and you can produce them. You can increase the amount you produce within a shorter time. So industrial automation, it also helps to reduce. AI also helps to reduce redundancy in industrial production. So very good. Pattern recognition. That's about recognizing patterns. And a related example to that, to pattern recognition, is what you do in your image classification, where you can recognize patterns in images and use that to extract a land use or a land cover. Because land use or land cover that have similar characteristics are likely to manifest, have similar spectral signatures on your imagery. And so that's a good application. We also have predictive analytics. This is very wide. Now what I'm doing here is I'm giving broad applications of AI before we zoom into surveying and mapping. Now in predictive analytics, this is very wide. You have those in the financial market who use AI. People want to stay ahead. People want to be able to know how is the stock price, the prices of stocks, or bonds or whatever. People want to have financial intelligence. What is likely to be the dollar naira exchange rate tomorrow? If I use that as an example. So you have in the financial market, people use AI for predictive analytics to stay ahead of what they're doing. Cybersecurity is also another important. Cybersecurity is also another very important application of AI in different fields of buy this, buy that. And what happens with e-commerce a lot is, with e-commerce, or what happens generally, when you use AI for predictive analytics, what happens a lot there is the AI studies your patterns. What are those products that you tend to buy? Or what are those, even in something as simple as doing a search, doing a search online. What are your search terms that you typically search for? You're on YouTube. You notice that YouTube can give you suggested videos. They can bring up suggestions for videos you should watch based on your, YouTube or other online platforms can give you suggested videos or suggestions based on your previous based on previous activity, that you've displayed on those sites. We have medical diagnostics for things like cancer, diabetes, and different ailments. AI is very, very useful and very important. It's very straightforward. If you have when you go to the hospitals, medical practitioners collect a lot of data. So if you have 1,000 people, who are diagnosed with cancer, and all these records are in the hospitals, and and the medical professionals, have the permission to use those data sets, they can plug these different data on people with ailments, into AI and try to learn what are the different conditions, or what are the different drivers of those conditions. And so in medical diagnosis, AI is very, very good for that. It's used in education, it's useful for marketing, it's useful for autonomous vehicles, facial recognition, smart agriculture. Now AI is being used a lot in smart agriculture. Right now, there are different ways that can be done. For example, you can have drone harvesters, that harvest fruit, or that harvest farm produce, and even you can train the system to recognize a fruit based on different characteristics. Maybe if it is diseased, or if it is ripe or unripe, or different characteristics. It's also used, AI is also used in gaming and finance. So it's very broad, and land surveying and mapping is not left out. And so, just as you've seen, AI is also being used in surveying GIS and mapping today. And that's what I'm showing on you on this next slide. And it's so wide, what I've done is just to summarize some of these application areas of AI in surveying GIS and mapping. The first one I put there is in automated cadastral mapping. Now, this is something I've seen myself. I know a lady who is using deep learning, in cadastral mapping. She's using deep learning in trying to, where you have cadastral boundaries and land. So she's applying deep learning to help with that demarcation. And that's something that is ongoing. That's the current PhD thesis of the PhD student. We also have AI-powered UAV mapping. And so your UAV mapping can be done in a very smart way. You can actually train an AI to detect or recognize different features, that are on the Earth when you're doing your UAV mapping. You also have, for example, if you are deploying drones or UAVs for agriculture and farming, and you want to do a selective, you want to do some selective, make some selective decisions on your farmland using drones. Perhaps, maybe in a fertilizer application, maybe in crop harvesting. AI is very useful there. We also have geovisualization, spatial data processing and analysis. Now, spatial data analysis is very wide. In spatial analysis, in GIS, we have master spatial analysis, you have vector spatial analysis. Even in your image processing, AI is used already. If you check your common software like GIS, you can already see, if you check your common software like GIS and, remote sensing software, you already see tools that are integrated there, tools like neural networks and other tools that help you with your image classification. Another application of AI in surveying GIS and mapping is in land cover change detection mapping. That is very big these days. There's a lot going on there. We also have multi-source data fusion. Now, data fusion is a very interesting field. It's interesting for many reasons, because data fusion involves the integration of data from different sources or data from different sensors. You integrate them together to improve the overall interpretation of what those data sets are giving you. So, for example, a good example of data fusion is what we call pan-sharpening. Pan-sharpening, in image processing, where you bring a low resolution multispectral image band, and you fuse it or integrate it with a high resolution panchromatic band. And that is a form of data fusion that gives you a pan-sharpened image. That's from remote sensing. Another example of data fusion is you might have observations that have different qualities. You might have tidal data, that is acquired from one instrument, with a different temporal resolution, and tidal data from another instrument with a different temporal resolution, and you want to fuse them together. It could be other things. It could be bathymetric data that was acquired from different sensors. You could have bathymetric data from sonar and from LiDAR, and you want to combine them together to improve the overall interpretation. So essentially, in data fusion, what you're trying to do is you want to look at the characteristics of those different data sets which are important for your work, see how they can complement each other and fuse them together. And I'm going to show you an example of data fusion as we continue in the presentation. We also have a prediction of natural hazards. Now, AI is very, very good for predicting natural hazards, for disaster modeling and disaster mapping. It's very good. Whether your flood mapping, your erosion, your flood mapping, your other disasters, landslide monitoring. AI is very, very applicable there. And if you just Google some of these things, you'll see so much happening there. We have environmental modeling. We have spatial data fusion. Okay, that's similar to what I mentioned earlier, the multi-source data fusion. We have image enhancement. We have geodesy and geodynamics. That's another very good area where AI is used. For example, your deformation monitoring, which also ties into your engineering surveys. And then we have coastal change monitoring. Coastal erosion, coastal flooding, just a lot going on along the coast. These are a few application areas of surveying, GIS, and mapping. Something else I haven't mentioned is in your land surveying, AI is also important for helping to reduce redundancy. So you have your data, you have a lot of operations, that you do in your traditional land surveying, and AI can help you to optimize efficiency in some of what you do in your land surveying. So very, very useful. Now I'm going to move on to, let's talk about some of the benefits of AI. Workflow automation. Now workflow automation is very, very important, because in a traditional GIS or mapping project, you will have a workflow. It starts with it could start with your desktop reconnaissance, your data acquisition, depending on what kind of mapping project it is, the workflow could vary. If it's a topographic mapping project, you deal with your concern interpolation from DEMs or from ground data. You may also have your post-processing operations that you have to do. So essentially, AI helps to automate workflows. And one of the benefits of automating workflows is that you can, when some things change, for you to execute that change across, very useful for generating insights. AI can handle very complex and nonlinear variables. AI is also robust enough for you to plug in a lot of variables. Sometimes even when your AI can handle them. Accelerated decisions, very good for accelerating decision making in your mapping project. Efficient resource allocation. Yeah, it's definitely a good way to allocate resources. When you use AI, whether it's human resources or material resources. Also useful for improved or beneficial for improved land record keeping. Real-time monitoring is another one, and it can also help to improve your data quality. Let me give you an example where AI can help you to improve your data quality. One of the common quality concerns in surveying and mapping is data gaps. So let me give you an example of data gaps. Example of data gaps is work with that data. You will notice that there is a lot of gaps in that data. There are some years or months, where some of the stations were not, either they were not functioning or some of the data was missing. One of the benefits of AI is that AI can help you in filling in gap filling. So where you have gaps in data, AI can help you to do some correction and to reconstruct the data. It could be in geodetic mapping. So AI is very good. It helps you with improving data quality if you use it efficiently, or if you use it for that purpose. Now, what I'm going to do now is still an ongoing. In some sense, there's still some things I still need to do, but it's still an ongoing work. What I've done is to employ machine learning to correct global digital elevation models. Now, a bit of some background there. When I say global digital elevation models, I'm referring to digital elevation models which are typically produced by satellite remote sensing. And first of all, when we say a digital elevation model, what are we talking about? A digital elevation model is basically a raster or a two-dimensional image. You just call it a picture, if I will put it that way. A picture that in which you found and get, you can bring those reduced levels, and plug them into your CAD environment and do some interpolation. You can bring it to your GIS and do some interpolation. You can convert that interpolated grid or those contours to a raster image. You have your digital elevation model. Sometimes it could be a digital terrain model, so it just depends on the scenario. Now, the difference between definitely you can't use spirit leveling. You can't say you want to run leveling to generate a DM for a whole country. And even if you do that, it's going to be very sparse. You can have a coverage of a much wider area. And so satellite remote sensing acquiring digital elevation for producing digital elevation models. What I've done in this work, or what I'm doing in this work, is I'm using global digital elevation models, which were produced via satellite remote sensing. And I'm looking at some of the errors, that we have in this global digital elevation model. There are different errors that you have in them. Don't forget that they are generated from satellites. And when you're sensing the Earth from space, there's a lot of errors that come into that. From the atmosphere. Error in the digital elevation model, in this case. And so we're interested in how can we screen out or reduce those errors in the digital elevation models that are caused by doing here. I'm applying machine learning to reduce those errors in the DEMs. Now, DEMs have a lot of applications, especially global DEMs. They have so many different applications. Use them in your environmental modeling, for your flooding, your erosion mapping, in your processing your gravity data. They are very important there. They are used in so many different applications. So it's very important to explore methods by which we can reduce the errors in DEMs. Essentially, when you do this correction and enhancement, it can help you to improve the accuracy and applications of global elevation models. Also, another reason why it is important to correct this error in them, at 30-meter resolution. Let's say 30-meter resolution or maybe smaller. If you can improve the accuracy of that global DM, it means that you can now start increasing the scope of applications. So perhaps you could only use that global DM for start bringing it down to city level mapping in certain applications. So that's it's